we're gonna work on the question graph valid tree. The question states, you have a graph of n nodes labeled from 0 to n minus 1. You're given an integer n and a list of edges where edges I equals AB indicates that there is an undirected edge between nodes A and B in the graph. Return true if the edges of the given graph make up the valid tree and false otherwise. So basically, let's look at their example. Here 0 has 3 nodes and then 1 has 1 node, and this is returning true because it's a valid graph tree. And if we look at their second example, we can see it returns false, and it's because there's a cycle here and it's not in a tree structure. So how can we determine from the edges that it's a valid graph tree or not? First, we need to make sure there are no loops in the graph, so that it does not contain cycles. And second, so they give us n right here. How many edges are there? There's 1, 2, 3, 4, which is correct. And for here, there's 5 nodes, but how many edges are there? There's 1, 2, 3, 4, 5. So actually, the number of edges should exactly be n minus 1 for it to be a valid graph tree. Okay, so these are the two constraints we found that denotes what is a valid graph tree. It doesn't explicitly state in this question, but we're going to follow this. And we can solve this question a number of ways. We can obviously use BFS, DFS, but I want to try to solve this using union find. Okay, let's start. Let's start with our union find structure. We're gonna initialize it, and it's gonna take size. If node equals self.parent node, then we return node. Otherwise, we just return self.find and then parent node. We just recurse this function until we find its root. And we're gonna have a union function where it takes node 1 and node 2, and if their root equal each other, we're automatically gonna return false because then this means there's a cycle here. And then otherwise, we are going to make we're just gonna make one of them the root. So this, our union function is done, and I'm gonna write our valid tree function. First, we can do a base case to check this. The number of edges should be exactly n minus 1. So if length of edges does not equal n minus 1, then we're just gonna return false right away. And then now we're gonna go through our list of edges. So the edges contain two nodes, right? And we're gonna connect them together. So node 1, node 2, and edges. If not union. Okay, so here we're gonna return true. If not union, node 1, node 2. Actually, I forgot to create the object here, so after the space case check, I'm gonna create an instance of union line called UF. I'm gonna pass in N, and then I'm gonna say if not union, node 1, node 2, then we're gonna automatically return false. And if it goes through this entire loop, then we're gonna return true. Oh, if not UF dot union self dot parent. Yeah, so this is how I would approach valid graph tree with a union find solution. Basically, we find if it's a valid graph tree if it contains a cycle through this union function. Let me know if you have any questions in the comments, and have a great day.